All right. So, hi everybody. This is the Tunisian Seawater Farm, the financial perspective by Vedant, Jack, Gabe, Vlad, and Jordan. The outline for this video will be that I'll talk a little about our group goal, our parameters, our collaboration with the Tunisian counterparts, the research and the discoveries that we made, and our conclusion. Our group goal was that we worked with different groups to research and find ways that would make the project financially feasible and sustainable in the long run. Our parameters were very, very simple. We had 1 million US dollars given to us to uh, make up for 5,000 people to provide them with food and energy. Our process was that we would communicate with other teams as well as our Tunisian counterpart. We would research average cost of living in Tunisia. We would do analysis based on our findings and then brainstorm potential futures for the project. Communication was a huge part here. A big part of our group plan as the finance team was to gather data and base expenses upon the other team's needs. Every member got assigned a team that should communicate with and hear out their game plans and try to figure out potential costs or expenses based on that team's needs. We also got assigned a Tunisian counterpart, Rania, that helped us out with understanding Tunisian culture and a little bit of economics by answering many of our questions. And so the data that we got back from her about everyday relevant information for this project at least was that Tunisia's main religion is Islam, which implies a few cultural things, specifically dietary restrictions. We know that livestock is common in Tunisian food production. We also know that the urban area Tunisians spent roughly 5 to 10 dinar on food per day. We know that Tunisians who have the option drink primarily bottled water, opposed to water from the sink. And we also know that there's unreliable water regulation, especially during the tourism season, because the water there is prioritized for the tourists, and so sometimes not everyone can have running water when they want it to be, when they want it. When it comes a little bit more to the labor side of the project, the numbers that we found was that the minimum wage is around 220 American dollars monthly for 48 hours of work a week. We know that many international companies are hired for larger, more modern products. More advanced projects are focused towards promoting tourism in the coastal cities, such as Tunis. There seems to be a cement shortage in Tunisia. We also know that rural areas have very limited resources for construction. And we also know that salary for civil engineers, who we assume would be using locally, is around 5,000 dinar, which is roughly $650 USD a month. From there on, we also researched a little bit of nutritional needs, just for the average human. We know that men need anywhere from 2,000 to 3,000 calories a day to maintain their weight, depending on how much they weigh. Women need around 16 to 2,400 calories, and we want to, apply these to be our new parameters for food. We also know that around 45 to 65 daily calories should be carbs, 20 to 35 should be fats, 10 to 35 should be protein for the average human. And from this, based on the information that we gathered from our Tunisian counterparts, Rania, we know, potential meal ideas that we have for a system could involve pasta, potato, chickpeas for carbs, eggs for fat and protein, and then tilapia, which is a fish in the area, as the main source of protein. For energy consumption costs, this slide has a lot of math on it, but just from all the data that we can find online, and again, Rania, the takeaway here is that we estimate that the average cost for 5,000 people right now is $450,000 to $750,000 a year USD, and so that's another parameter that was created for us. So from there on, after we got all this information, we now have new parameters, based on energy and nutrition. We know that we have to, when implementing this project, we have to stay with those parameters. And so we got assigned we assigned each finance member to another team. Jack and Vedant got engineering, Vlad got law and culture, Jordan got the environmental team, and Gabe got agriculture. And so we spoke to about different processes and ideas they would like to implement with the other teams. The team members then decided to research the financial feasibility of these ideas. Um, so from there on, one solution that we really spent a lot of time on that we figured wouldn't be feasible would be solar panels, just because due to modern costs of the implementation of this, or would although it could work, it is just way over budget, almost 10 millions alone to support 5,000 Tunisians over a 25-year period. Um, Although it would be a great place for it, it's not the most viable solution. And then from there on, we move to aquaponics. Um, and so, what is for our potential feasible solution? And what it is that it is essentially the most efficient way to use the filtered seawater. Um, the filtered water is stored in tanks with fish aquaponic plants and act as biofilters. They convert the remaining waste into microbes that will help the crops grow. The water is supplied to the farm beds where the plant absorb the nutrients and add plant waste to the water. Almost 90% of the water with plant waste is supplied back to the tank, completing the cycle, as you can see in this picture to the right. We use a model to make financial estimates about our own project. The one that we used is this report by the Agriculture Experiment Station at the University of the Virgin Islands. On the right side of the slide, you can see that the plants and fish that commercial favorites are the commercial favorites for an aquaponics farm. For our financial model, we will be growing lettuce with the help of tilapia in the tanks. These are weekly production estimates for the greenhouse. As you would have noticed, although the market price is almost twice the break-even price for lettuce, tilapia market price is lower than its break-even price. So using these costs, we would have to equal out, the return that we would have from our system. Obviously, hoping to sell more lettuce than we would tilapia, and maybe using tilapia more for consumption and lettuce for profit. So for the budget sheet here, we focus on the rightmost column, as that is the ideal model we would like to reach. As you can see here, the total cost of a setup was $1,004,898, which is just above the 1 million threshold that we have in the parameter that we're given by Kent. Although we will not start with 24-unit farm, we'll begin with a 6-unit setup right here, and then scale up to the 24 units. From this system, the parameters and everything that we've gathered could be more sustainable in the long run. Brine is one of the byproducts of our water filtration system. It is a salt concentrate liquid. Initially, we thought of brine as waste, and we're brainstorming ideas as to how we can best deal with the waste. That is when we found that brine can actually be sold commercially at an industrial level, which can give us a little more profit. And so what's better is that we actually found a Tunisian company that purchased brine called Tunisal. So that can also be incorporated into our system for profit and sustainability. From there on, that's the end of the presentation and the video. Thank you so much for watching. Have a wonderful day.